Hi guys, this is Ms. Miner, and this is um, lesson 3B, and we are going to be working on determining whether something is a function from a graph, map, or coordinates. That's our ultimate goal. That's what we want to be able to do when we're done with this. So let's just start out right now with a quick little poem. I love Shel Silverstein, and so this is one of his poems. And it says, "The homework machine, oh, the homework machine, the most perfect contraption that's ever been seen. Just put in your homework, then drop in a dime, snap on the switch, and in 10 seconds' time, your homework comes out, quick and clean as can be. Here it is, 9 plus 4, and the answer is 3. 3? Oh, me. I guess it's not as perfect as I thought it would be." And we use functions in the real world. A lot of times you've heard about functions in relationship to computers, right? You have a function button on your computer keyboard. Well, functions are little pieces of equations or computer code where it's very specific. Whatever I put in, I should get only the expected answer out. And so we use functions to do very specific things, especially when we're coding computers. When I press the A button on my computer, I only want it to type an A. I don't want to sometimes type an A and sometimes type an E. Something is wrong with that function if I'm not getting the expected result. And so I like this poem because she's expecting a certain result on her homework, right? And then she gets out something totally unexpected. And so she's like, oh, I guess it's not. But if you'll look in here, this is what is funny about Shel Silverstein. There's a little dude in here, right? She's trapped a little guy in there to do her homework. And so, he's just funny. Shel Silverstein is really funny. He writes a lot of really funny poetry. So, okay, let's talk about functions. Oh yeah, there he is. A function is like a machine, okay? And so we want to put something in, an input, and we want to get something very specific out. We want to be able to know what our output is going to be, and be able to use that to help us get what we want, right? We use functions because they are very specific. Okay. So a function, here's some really good vocabulary. Make sure you're filling in your notes. A function is a relation or a relationship, right, in which each value for my x variable. So in here, you're going to write in the word x variable. Each value for my x variable is paired with only one value for the y variable. So whatever my data is, whatever my little function is doing, when I put an x variable in, it should only give me one y variable out. And it should give me the same y variable every single time. So we are going to be using something new in this lesson, and it's called a domain and range map. Domain and range are just another way, it's a synonym for the x variable and the y variable. And so you're going to talk a lot more about domain and range when you get to 9th grade. But for right now, the domain is the x variable, and the range is the y variable, or the set of those things. So the domain is all of these x values, and the range would be all of these y values. So for my class purposes, for this year in 8th grade, we won't use domain and range much. But by the time you get to 9th grade next year, they'll start using domain and range, and you'll work a lot more with that. So for right now, we're just going to call this an XY map, or we can still call it a domain and range map. We just have to understand that the domain is the X values and the range is the Y values. And we'll learn how to write or draw a domain range map in this unit. I just wanted to let you know, and we'll talk about what that is. So let's talk about what the x variable is. Some other names or some other things that the x variable is known as is the independent variable. We've talked about that in my class. And the y variable is the dependent variable. The x variable is also known in, this is the thing about functions, right? The x variable is going to be our input. So let me just get a different color here. The x variable is going to be our input. And then our y variable is going to be the output. It's going to be the thing that we want to be able to kind of predict, or we should kind of be aware or know what our x value is going to give us, because it should give us the same y value every time. Okay, so in a function, the x variable is going to be our input, the y variable is going to be our output, and then the last thing that we could add to this then is the x variable is also known as the domain, and the y variable is known as the range. And so those are just synonyms. They are the same as saying x variable. I could also say the independent variable, and that just means my x variable. I can also say the input. That means my x variable. They're the same thing. They're synonyms for each other. Okay, so let's specifically talk about a function. A function is like a soda machine, okay? In the real world, a function kind of works the same way as a soda machine. And a function is just, it's an equation or a graph or a set of data. And it can be any of these things. But it specifically has one x value that only gives me, or input, right? That only gives me one y variable or one output every single time. So it kind of works like a soda machine, right? If I push the Fanta button here, I should only get Fanta out, right? My input should only give me one output. If I push the Fanta button and I get a Diet Coke, that's not the expected result. That's not what I wanted, and that makes me mad, right? That function is not working, okay? That is actually not a function if that happens. So if I have an input, right, it is not allowed to give me two different outputs. A function is not allowed to have one output go to two different outputs. I don't want to push the Fanta button and sometimes get Fanta and sometimes get regular Coke, because regular Coke is disgusting and no one should drink it. Okay? In a function, I should always know what I'm going to get. Okay? And you may or may not know, but your data should at least tell you that you're getting the same thing every time, right? Whatever your input is, it should give you the same output every time. Okay. Now, it is okay in a function to have two different inputs. So I can have two different inputs. Here's two different buttons, right? I could push this button and it could give me Diet Coke. I could also push this button here and it could give me Diet Coke, and that would be okay, right? And so I can have two inputs, two different inputs. Let's put that in our notes. Two different inputs go to the same output. Okay. So here are our inputs, right? Our x values, our domain. A function is like a soda machine. If I press the button for regular Coke, I should get regular Coke out, right? This is my output over here. And remember, this is the x values and these are the y values. It is okay if I have two different inputs giving me the same output. But I cannot have, in a function, input going to two different outputs, right? I couldn't sometimes get Fanta and sometimes get Mr. Pibb. That's not what I want, right? So in order for it to be a function, each individual input can only have one output. Okay, so here's my domain and range map. We're going to determine if this number 1 is a function or not. And so if it is a function, we're going to write yes. If it's not a function, we're going to write no. Okay, so in this set of data, here's my input, my x values, here's my output, my y values. I have a -2. It only goes to the -3, right? I have a 0. It only goes to 6. I have a 3. It only goes to 6. Now these are both going to the 6, but these are just two different inputs going to the same output. Is that okay? Hopefully you said yes, because that is fine. I can have two different inputs give me the same output. That still will qualify as a function. Now the 4 is only going to the 9. So this one, yes, it is a function. Okay, let's look over here. Here's a data table. Remember, my domain is my x or my input, right? And my range is my y values or my output. And so let's just take a look at this data and see what's happening. When I put in a 1, I got out a 4. Okay, then next in my function, I put in a 3 and I got out a 2. That's okay. Then I put in a 5 and I got out a 4. Oh, here's two numbers that are the same, but they're my output numbers, right? Is it okay to have two different inputs give me the same output? Yes, that is okay. But when I move on to the next one, I have another 1, but this time it gives me a -4, right? So here's a 1, here's a 1, but this one gave me a 4, this one gave me a -4. So is it okay to have the same input give me two different outputs? No, that is not a function. Okay. So let's just keep going. Let's do a couple more of these, right? Let's do a few more of these and see how it's going. This is a x, this is a y, so this is my input, this is my output, right? This is my x, this is my y, input, output, input, output, input, output. So in an ordered pair, right? These are just different ways to express the same kinds of information. We're just looking. When I had one input, did it give me only one output? Oh, sorry, I hit the wrong button. Okay, when I had a 24, right, I got a 1. Then, if I'm looking at this, I put in a 24 again, but this time it gave me a 5. So as I look through this data, this one would be okay right here. 21 and 4, right? And 3 and 22 would be okay. That's fine. But I had a 24, I put a 24 in, and the first time I got out a 1, the second time I put a 24 in, I got a 5. And so that one is not okay. It is not a function. All right, here's a domain and range map again. This one looks kind of crazy, but I just kind of follow the arrows on these and I try and match it up and see where it's going. Make sure I have only one output for each input. So I had a -1 and it only went to 9. Then the next one I had a -2, it only went to 8. I had a -3, it only went to 7. And then I had a -4 and it only went to 8. So each individual output only had, or input only had one output. So that one is okay. That one would be yes, that is a function. Okay, this one over here, let's look at this because it looks like I had a 3. The first time I put in a 3, it gave me a 4. The second time I put in a 3, it gave me a 4. So would that be okay? Each time I put a 3 in, I got the same value out. Would that still qualify as a function? Yes, yes it would, because those were the same outputs every time. Normally in a domain and range map, we don't double up on number copies. We would just draw our arrows, right? But this one is just trying to illustrate a point. Okay, now number 6, last one, the -3 gave me the 0, right? But then I put in a 2, and the first time it gave me a 1, the second time it gave me a 4. So this one would be no, it's not a function. So I'm just checking to make sure that I have one, my input only has one output every time. Okay. What about from a graph? How do I tell if a graph is a function or not? And we use what's called the vertical line test. And if the vertical line intersects, that word intersect, it means crosses. Okay. If the vertical line crosses the graph more than once, then it's not a function. So let me get a vertical line out here, right? And here's some illustrations of functions. So there's my vertical line. If I took a vertical line at any point on this graph, right, and I kind of, as I move it across, right, if I'm looking at any time as I take this vertical line across here, is it ever touching more than one place, right? As I move it along here, it's only touching at one place or only crossing at one place, right? And so this graph would be a function. It already tells me right here, but I just am trying to illustrate what the vertical line test means. If I took a vertical line and kind of put it across this graph or drug it across this graph or moved it across this graph like that, if it's ever crossing at more than one place, right? This one is crossing that vertical line at 2 different places. So this one is no, it's not a function. Because sometimes I'm getting this value for y and sometimes I'm getting that value for y down there. Over here, this one, if I put it right here, this one's tricky because right here at this place, like this almost looks like it wouldn't be a function, right? Because right here at this spot, I have this one place, right, where it looks like possibly my vertical line, oh, come on, vertical line, there we go, might be touching both of those, right? But remember what we know about open circles and closed circles. So this graph is not included up here where there's an open circle, and it is included down here where there's a closed circle. So this one is a function because right here at this one spot where it looks like it might be touching twice, it's actually not because I have an open circle up there on the top graph. So we have to be a little bit careful about looking at. So why does the vertical line test work? Because if I look at this, right, each spot on this graph represents a point. Each spot on this line, this swervy line, represents point values, right? And each point is an input and an output. And if it's crossing a vertical line at 2 different points, what it's saying is, well, my x values are matching up. My 2 inputs are the same at that spot, but my output values are not the same at that spot. And so this one is not a function. Okay, this would be a non-function graph. All right, okay. I'll erase all of my writing so you can kind of see that graph again really clearly. Okay, so all linear equations are all linear equations are functions. What is a linear equation? A linear equation is a graph that makes a straight line. See how it says it in the makes a straight line. Okay, so all line graphs are functions except vertical lines. And so to illustrate this, let's just kind of see this straight line is going to pass the vertical line test, right? Anywhere where this vertical line kind of goes across, it only crosses at one spot, right? It doesn't cross anywhere else. And so any line graph, any straight line graph, we call those linear equations, okay? They're always going to be functions, except for a vertical line. Because what happens if I put a vertical line right here where that vertical line graph is? Well, it touches at every single place, right? The vertical line cannot pass the vertical line test because they are the same, right? And so if I stick that black line on top of that red line, it's touching every single point and value on that line. And so the vertical line cannot pass the vertical line test, so it is not a function. It can't pass the vertical line test. This one would be yes, it is a function. Okay, so the rule is all lines are functions except vertical lines. Okay, so let's kind of look at some graphs and decide if they're functions or not functions. As I drag this along, right, is there any place where it's touching more than once? Well, yeah, if you look at this graph right here, see how it's touching everywhere right here in this section. And so anytime there's these little vertical line parts, right, they're going to touch that vertical line in more than one place. And so this one would be no, it is not a function. If I take my vertical line over to this graph and try again, would this one be a function? Well, right there at that point, it touches once, but right here, look at those 2 points right there. They're both on my vertical line at the same time, and so this one would also be no, not a function. Okay, let's try again. What about this one? Well, the only place is right here, right? If you'll notice, this graph has this little dot up here, and then also it's touching right here on my vertical line, so this one is no as well. If it's going to be a function, it can only touch a vertical line in one place at one spot at a time. So what about this one? As it moves along here, it's looking good, and then boom, what about right here? Does that work or not work? Well, because this one here is an open circle at that point, and this one here is a closed circle, that will actually work, because then it's saying right here at this place, the top place is open, so it is not included at that point, but it is included down here at this bottom one down here, and so this one would be yes. So so there is some practice with graphing and the vertical line test. Okay, last but not least, we want to be able to create a data table, a graph, and a domain and range map, or an XY map, from a set of data. And so we want to I've given you some data up here. Here's our data. And we want to be able to create a table, a graph, and then a domain and range map. So let's start with just the table of values, right? Each one of these ordered pairs up here is a value for X and a value for Y. And the X value always comes first, and the Y value always comes second. And so I can just put them on the table just exactly as they are. I just want to get all my x values in here where the x values are. And I'm just going to fill this table in, and then I want to get all my y values, and I want to make sure I get the right y value partnered with the right x value, right? So when I put in a 3, I got a 2, and when I put in a -1, I got a -3. Then I want to just go ahead and graph these points. So when x was 6, and this one's actually, this graph isn't quite big enough, so it's going to go off the graph by 1, but it's out where x is 6 and y is 1, where x is 4 and y is -3, and then where x is 3 and y is +2, and this is just regular old graphing points, right? And then where x is -1 and y is -3. Okay, so now we have created a table and a graph, and that's just review. We've done that kind of stuff before. Let's talk about a domain and range map, or an input-output map, I guess is something that might be a little bit more familiar to you. And I want to take all my inputs, and I kind of want to order them from greatest to least. Greatest to least, okay? So on a domain and range map, I always take my biggest x value and I put it at the top. So 6 will be the biggest x value, and then I kind of go down from there. Then 4, then 3, then -1, okay? Then I do the same thing with my outputs, or my y values. I put them in order from greatest to least. So my y values, the biggest y value was a 2, and then the next would be a 1, and then finally the -3. And you can see I have multiple -3s. I usually only list one of those because the next part of this is going to be to draw my arrows from the input to the output that it belongs to. And I can just draw an extra arrow when I have that extra -3. So I'm going to start by drawing an arrow from the 6 to the 1. Then I draw an arrow from the 4 to the -3. And I draw an arrow from the 3 to the 2. And I draw an arrow from the -1 to the -3. And so it's pretty simple to create a map of your inputs and outputs. All right, so pause the video right now and practice doing a domain and range map here with this data. Practice doing a graph and a data table. See if you can do it on your own. And then you can come back and check your work and see how you did. Okay, so hopefully you paused the video and tried this on your own. Let's go back and check your work and see how you did. If I'm going to create a table of values, all I do is I go down through and I just list all of my values just as they are. I could put them in order if I wanted to. I could kind of like order these so that they were kind of in numerical order, if you will, but I don't have to. Okay, then I want to graph it. So same situation here. I'm going to go where x is 4, y is -3. Oops. Let me erase that little mark I did with my pen there. And then where x is 1 and y is +3. And remember, I'm just going over to where x is 1 and then up to where y is 3 on these. I'm just counting the boxes. Then x is 7, so it's going to kind of go off the graph, right, out here somewhere. And then we'll just kind of estimate where that one is. Then where x is +2 and y is -2, and then where x is 1 and y is 5. Okay, so then I've graphed my data, and now I want to make a domain and range map. So I'm going to take my greatest x value, which is 7, and put it at the top, and then kind of numerically go down from there. Then 4 would be the next one, then 2, and then 1. And remember, I only use one one time, even though there's two ones. On a domain and range map, I just put in what the individual values are, and I don't worry about duplicates. Okay, then over here, my greatest would be 5, and then 3, and then -2, and then -3. And then I want to go back in and just draw an arrow to each matching partner pair. So 7 was partnered with -2, and 1 was partnered with +3, and 4 was partnered with -3, and 2 was partnered with -2, and then 1 was also partnered with 5. Okay, so now let's decide. Are these two examples functions or not a function? Hopefully you've already decided in your mind. This one is, yes, it's a function. This one is, no, it's not a function. So now we know, and we can see our data. We can also see this one didn't pass the vertical line test, right? There were one input with two different outputs. I have two arrows going from the number 1 to different numbers on my output side, and so hopefully you are kind of starting to see how that works. Okay, so again, what I'd like you to do is go ahead and pause the video and trying to determine if these, are functions or not a function. And then after you've paused the video and tried this out on your own, you can come back to the video and check your work. Okay, so let's take a look at this graph. If I drag this vertical line, let's erase my little mark that I made there. If I drag this vertical line across, you can see that at any given place on this graph, that vertical line only touches once. So this one would be a yes. And the reason is it passed the vertical line test. Over here, I have only one single output, right? I'm putting a 2 in every time, but I'm getting a different number as my output every time. So this one is no. Oh, sorry, I touched this one is no, because 2 could only have one output. Okay. Here's some more examples. I'm going to kind of skip ahead. I think that's all that we have. So try some of these on your own if you need some more practice, right? Actually, maybe pause the video. I'll go ahead and put the answers on this in just a minute. So pause your video, try again with these last few examples, and just see how you do. Okay, hopefully you paused the video and you've practiced on your own. But if you'll notice, when I drag my vertical line across, right, this one actually touches the vertical line at every single point. So this one, again, would be a no, because vertical lines cannot pass the vertical line test. Right? I'm kind of abbreviating some of these things, and it's okay if you abbreviate it on yours too. Okay, last but not least, we're going to look at this one output for each of these inputs. So this one would be a yes, and so because one output for each input. Okay, all right, and there you go. There's your last notes for today. And if you have any questions on your homework assignment, please feel free to email me or Mrs. Zeider, and we're happy to